Today's episode we'll be going over a D1.1 1G 1-inch thick unlimited thickness welding plate. We're going to be using 045 ER70S6. Let's get right to it. Alright, we're going to prep our plates by sanding the faces and removing all the mill scale on the top and the bottom of each plate, as well as removing the mill scale off of the backing plate. And so best practice that I've found is to use clamps to hold the plates down so that when you're tacking these together, they don't bow up. So we're going to use the backing plate because it calls out for a 1/4 inch gap. The backing plate's 1/4 inch as our gap setter, and we're going to clamp it down and get it ready to go. One important thing to note is when you're first welding it together, just tack it, is my advice, to keep it from going anywhere, the backing plate from pulling off of there. Once you get 4 tacks on there, you're ready to put your stitches on there. One other thing to note is do not go more than 1 inch past the ends because that gets into your test zone, and it's generally frowned upon to do that. So let's put some good stitches on here, and don't just tack it, stitch it, because when you're putting that much weld on the front side, it's very easy to pull and break those welds if it's not good. So we're going to show the direction of travel here. This is typically the angles that we were going to use. Pick what works best for you, and let's run with it. Another thing we're going to shoot for is 5/8 to 3/4 of an inch of contact to work distance. So this will be important because it allows us to get down into the root of the plate here. And this should look something like this. So as we get started with this, we're going to start by putting a weld pool on the leading edge of the plate there and just carry our weld all the way through. So one of the things that I like to do is do just a slight little weave like this at the bottom. This allows the weld to tie into the root down inside of there, into the sidewalls there. And honestly, we're going to show a lot of arc shots with this because the root is one of the most important. So we start on the outside there, as you can see, and just carry it right on through. Note here how that I'm just ever so slightly wiggling the puddle in there, not really a weave, more of a wiggle to bite into the sidewalls. So notice here how it is wetting very well at the toes of the plates there. No lack of fusion, no undercut or anything like that. It's wet in there just fine. And don't forget to build up the ends so that you can get build up toward the end of the plate as well. As we look here from the back side, again, one more time, another opportunity to look at how it's wetting on the sides. Nice and even, no undercut, and it'll allow us to have nice clear lines when we put our second pass in. So as we go to our second pass, I recommend that you do a slight weave, kind of similar to what we did with the first pass there, to build that up and allow it to wet in nicely on the side walls. I've had very good luck with this. I've had no test fail by doing this, and so I recommend that you try this as well. You could stack stringers in here, but that creates problems, and you'd have to go pretty quick so you can get down inside of there with the third pass in there. So again, go back and forth here and then go to the stringer method. And here's what our second pass looks like. Notice how it's nice and smooth. There's no signs or obvious signs of lack of fusion there. Nice and even, especially on the sides there, which is going to be very important when we go to put our third and fourth passes in. It gives us nice defined lines to follow to the best of our ability anyway. And again, it's nice and smooth, nice and even. The method of walking back and forth or a slight little wiggle there seems to work very, very well. All right, as we get on to the third pass here, it's just like doing a fillet weld. We're going to aim for the bottom of the plate in the corner of the weld there, overlap the weld by 50%, the other 50% on the side of the plate. And this method will allow you to bite into that sidewall, and when you do your bend tests, you won't have lack of fusion. Also remember to, at the end here, add a little bit of extra filler, and continue to do so as you move forward so you can stack your beads great. Amperage is holding around 27 volts, 250 amps. And this is what my third pass looks like. Nice and even. You'll notice as we have aimed for the previous pass and it was nice and straight, it helped us to make this pass nice and straight. And again, it helps us to stack our beads as we move forward. And so if you can do this throughout the whole test, it's going to make the welds stay straighter and look a lot better. Notice the toe of the weld, how it's nice and even across the top. And then my bottom toe is roughly a little bit past center on the pass before. That gives me plenty of room to come in here with the gun and come the other direction. So we're going to come in here and do a dry run. This is how I'm going to do the fourth pass here, aiming for the bottom of the plate and the weld before that. If you can focus it right down inside of here and follow the weld, again, keeping it straight from the last pass, it's going to work out really well. So aim again for the root of that, the sidewall, and the weld before. All right, from here moving forward, everything else is pretty much identical to what we just have showed you. You're going to stack your beads, overlap by 50%, and then just keep being as straight as you possibly can. So I'm going to speed this up so you can at least see my body motions and how that I do. I'm building up the ends of the weld so I can keep it nice and even for the top, and I'm also using a wire wheel to get rid of everything that was left behind from the weld before, because again, it's not really going to help you any, and it does make it a lot smoother and a lot nicer. And again, watch the body motions, watch how we're doing this here. And again, if you can keep doing this for every pass, it brings it up nice and even for your cover passes. And that is my passes up to the top. And so we're getting ready to do the cover pass here. And I just want to show multiple angles of what I prefer it to look like slightly below the surface of your plates here. And again, at the end here, I built it up so that it keeps it nice and even. By doing this method and having it just like an 1/8 of an inch or 1/16 of an inch below flush, usually by putting that next pass on, you are below your 1/8 of an inch reinforcement max that most people require, and you also still have good guidelines in putting your next passes in. So note here that I have what technically would be called undercut on this side over here. The other side was nice and straight, and I did nip a little bit on the other side. Not a big deal since we're putting a cover pass on, but it will be a big deal if it was a final weld and you don't want to nip those sides there. Also, that straight edge is going to make it a whole lot easier to put your cover passes in, something easier to follow. So I'm going to use a backing bar just to show you roughly how far down the weld is. It's a little bit less than 1/8 of an inch. So I'm aiming for the straight line that I have there. Unfortunately, I didn't stay too straight. Apparently, I got too nervous recording for everybody watching this or something along the lines, and not my finest moment, not my finest pass here, but technically it will still pass and it'll still be fine because there was no undercut present, as you can see here. Not the prettiest, but it'll still work. And so for our next pass, we're going to aim to overlap the previous weld by 50%, aiming at the toe of that previous weld. This will allow you to have obvious good fusion with the previous weld, but it also will allow you to build up to that 1/8 of an inch that you were going to shoot for as your max reinforcement. When you get to the end right here, don't forget to build it up. Do a little trigger motion like we did here so that it allows you to build it up and not be underfilled. Here, as we get to the last pass, we've got a choice to make. So we can do one single pass across here, which is what we're going to do in the end. Or, depending on where your beads are placed, you can do 2 more passes. Again, check your procedure here that you might be working to see how much farther you can go over the weld or over the plate here. But if you could do 2 passes, you would have to do 2 very quick passes so that you can actually get inside of there. Again, we're going to choose to do 1 aiming at the bottom of this weld right here. And that is my 1-inch ER70S6 045 test plate. The beads came out okay. I wish the one on the right was a little bit straighter, but technically it'll still pass. You can see here that there's no undercut, nothing that we can see. We took a gauge and checked everything. Everything is just fine. The other weld came out pretty straight and pretty good, actually. If you can keep the welds as straight as possible, it looks really good, and there's less chances of any inspector looking at that saying, hey, you know, what's this? Is this undercut or a lack of fill? Here at the end, remember we told you to build things up and trigger it there, and we did it on both ends. Actually, we focused hard on making sure they were built up just fine so that we didn't have to go back and try to fix it at the end. And this is the final weld. You know, I'm proud of it. It's not the most pretty, but hey, it'll still work. I hope this episode helped you in taking your 1G 1-inch weld test. Again, we use ER70S6 045 on pulse using our Miller 350P. Our settings were about 40 on the trim, 350 to 360 inches a minute, which translates to about 26 to 27 and a half volts. And again, if you have any questions on this, shoot us a message or comment below the video. We look forward to seeing you on the next episode.